look at coin change 2 problem. So we are given a set of coins and we have to find the number of ways, the number of combinations in which we can come to the amount 5. So that's the problem, and we can use each kind of coin infinite number of times. So we can go with the exhaustive solution, and when you solve that, basically trying to get all the combinations and getting the maximum out of it, uh, getting the total number of out of it, it is going to give you a time limit exceed solution. So we will go with a dynamic programming approach, and this is a DP table. So what we are going to do is we have the amount 5, so we will keep the number of columns as the amount that we need to calculate, which 5 being the maximum, 5 being the amount given, right? On each row we are going to have the denominations given to us, and we are going to fill this table now, and we are going to fill this table in a way where we don't recompute the values which have already been calculated, and we'll see how we can do that. All right, so how to fill this table and how to understand this table. So let's start with the first one. You have zero amount and you have zero coins. So basically what we have to do is we have to make sure that we choose or don't choose, right? So either we choose a coin or we don't choose a coin. What happens if we choose a coin, and then we have to see what happens if we don't choose a coin, right? So in this way, in when the amount is zero and we have to make we have zero denominations and the amount we have to make is zero, what do? We don't choose. So that's one way, right? So that's why we have one over here. Okay, now we increase the amount has become one. Now we have amount 1 and we have zero denominations. Can you make the amount 1 if you don't have any money? No, right? So there are zero ways. Similarly goes for this. You have to make 2 but you don't have any coin. Then you cannot make 2, right? Whether choosing or not choosing doesn't make sense because you don't have any coins. That's why this is going to be 0. So everything in the row is going to be 0, meaning if you don't have any coins, you cannot make any amount, right? And the question of the number of combinations doesn't exist then, right? Now we go to the next row. Now we have amount 1 and we have one coin. All right, can we make 1 using one coin? Yes, we can, by choosing it, right? If we don't choose it, what do? If we don't, so we can, at this position we have a choice whether to choose or not to choose, right? So if we choose the coin, there is one way where we can create, where we can come to the amount 1. If you don't choose, there are zero ways to do it, right? So if you don't choose this coin, you have zero coins, and we have already seen in the previous row that we cannot make anything, right? So in this location we are going to put 0 plus we have to put 1 here, right? That becomes 1. So there is one way to create amount 1 if you have a denomination with value 1, right? Let's look at the next one. You'll understand it. Stay with me. Now we have two coins. We have the amount 2 and we have one coin. They have told us that we have infinite number of each kind of coin, right? So can we make 2 using coin 1? Yes, we can do it by choosing 1 twice, right? 1 plus 1, that gives us 2, right? This 2 is the amount, right? And this is the number of times we have chosen 1, right? So that is one way of making 2, right? Don't put here 2. This is wrong. We have to write the number of ways, number of combinations, right? So 1 plus 1 is one such combination. That's why we wrote 1 over here. Okay. Now to understand further, let's see how we are going to do this dynamically using a dynamic programming approach. So what we do is if we don't choose a coin, if we don't choose 1, we go one row above. Since we have not chosen this, we know to make 2 with 0 denomination, there's 0 ways, right? So it's always going to be 0 plus, right? Not choosing, 0 ways from here. And if we do choose, what we have to do, we have to take 2, we have to take 2 minus the denomination which we have used, 1, which is 1, right? Now this particular 1 is nothing but the remaining amount. This one is nothing but the remaining amount. Now we have already calculated the remaining amount in the previous column, right? Which is this one. So basically, this one is indicating the remaining amount which we have done for this particular amount, which is 1. That particular 1 is what we are going to write over here, right? So 1. Let's go further. We have 3. If you don't choose the coin, it's 0, right? If you don't choose a coin, we don't choose 1, we go up 1 row above this. But if we do choose a coin, what we are going to do? We have 3 minus, which coin have we chosen? We have chosen coin with value 1, which becomes 2. Now we have 2, which is the remaining amount. But we have already checked, we have already counted the number of ways which you can create 2 having 1 denomination, right? Where have we calculated that? I've calculated over here, right? So we take this particular value, which is 1 again, right? Same goes for 4. In how many ways can we do this? If you don't choose it, it's 0. Plus, if you do choose it, 4 minus the denomination that we have chosen, that is 3. 4 minus 1, 3 is the remaining amount, and 3 can be done only in one way. So this also becomes 1. Same goes for 5, right? So that's how we do it. Let's now things will become more clearer, okay? So same. We have to make 1 and you have the coin 2. Now this is where you need to think. If I want to make 3 with a 5 coin, can we do this? We cannot do, right? We have a coin with value 5, but we have to make 3. We can't do this. So we have to make sure this particular condition is checked, okay? So in this case, we have the value 1 and the amount that we have is 2. We cannot make 2, we cannot take 2 and make 1, right? So we simply copy the previous row's value, meaning we do not choose this coin. We have not chosen 1. We have not chosen the denomination 2, 1, right? So we check this whether this is bigger than, whether the denomination is bigger than the amount we are making, okay? Next, we come over here, we see, oh, this is the amount that we need to make, and we have to choose 2 or we do not choose 2. If we do not choose 2, we go one row above, meaning we have only denomination 1, and we have to make the amount 2, which can be done in one way. So this becomes 1 plus, we do choose the coin. What if we choose the coin? It's 2 minus 2, which is 0, right? So you come and check this, right? Because we have to make 0 with the denomination 2, and there is one way to do so because we do not choose that coin, right? If we do not take 2, we make this particular 0 amount, and that amount is that particular number of way is 1. So this becomes 2, all right? So this is how we are going to solve the table. Same goes here. Now I'll go a bit faster, okay? So 3, we have to make 3, and we have a coin 2. Can we do it? Yes, we can do it, right? So we don't choose 2 first. If we don't choose it, we go one row above. That's 1 plus 3 minus 2, that's 1. 1 is the remaining amount. We come over here. This is the remaining amount, and this is the number of ways which we have already solved. Then this becomes 1 plus 1, that is 2. All right. Same, we do it over here. 4, we don't choose it. 1 plus 4 minus 2, that's 2. We come over here. Oh, we have two ways to uh, get the remaining amount calculated in two ways. So it's 2 over here. 1 plus 2, that's 3. So this becomes 3, right? Now the last in this particular denomination, we have to make 5, and we have the coins 1 and 2. If we don't choose 2, we have one way to make it. 1 plus, and now we choose the coin 2. 5 minus 2, that's 3. 3 is the remaining amount, and the remaining amount can be calculated from here, taken from here. That's 2, right? So that becomes 3. 1 plus 2, 3. Now this is the interesting part. So we have a coin 5, and we have to make 1. Can we make? No, we don't choose that coin. So simply copy the previous. We have to make 2, and we have a 5 value coin. Can we do it by choosing 5? No, it's going to be more than that, right? So this becomes 2. Same for here. We simply copy the values above by not choosing 5. But in the last column, in the last column and row, we come 5. So now we have the options to choose 5 or not choose 5. If you don't choose 5, it's going to be 3. Right? Now if we choose coin 5, we remove 5 because we have chosen it from this, and now we get 0. And we can create 0 by using a 5 denomination coin in one way. We add it over here. So that's 4. Right? So this is how you fill the table of the this is how you fill the DP table, and the answer is going to be the last value in your table. That's DP of -1 when you're doing it in Python. And the answer is 4. That's how we got 4, right? So this is the logic behind it. I hope you understood it. I tried to make it easy though. But if you don't understand, you can put it in the comment and I can clarify it. So let's try to code this up. Now we have a 2D array. So we'll do that by creating a DP variable. From 0 to amount plus 1. So that's 0 to 5 plus 1, which we have. That's 0, 1, 2, 3, 4, 5, 6. Okay. And then inside this, there would be another loop. Right? So length of coins plus 1. So 1, 2, 3. And then this is the 0th which we are adding, right? So this is our DP uh, table made. Next, if you see, we have always have the first column as 111 because there are one way of not making the value 0 by not choosing any of the denominations, right? So we can fill that directly. Right? And that's how you fill the first column. Now let's go and make the fill the rest of the values. All right, so all right, so for we start with 1 to the length of DP, and for j in the range of 1 comma length of DP of 0. Right, so we're starting from here. Okay, and the 0 is already filled in everything, right? So we're starting from here. So what do we do? So first we need to check whether the denomination is same or not, right? So if this is less than the denomination, we just take the previous values, right? So if j is less than the previous than the denomination, if it's less, we just fill the value of I comma j as dp of I minus 1 j, right? So this particular thing is just copying the previous row, right? Just which we saw over here. Okay, we do this now. Else dp of I comma j, what we do here is we take, so here is what we write, the choose and not choose, right? So first we don't choose it, so not choose plus choose. So if you don't choose it, what we do, just take the value from the previous row, right? Plus now we choose the value, so dp of I becomes dp of I. Now we need to do, at this location, what we need to do is, like, we have to do 3 minus the denomination. Okay, 3 minus denomination, so that would be j minus the denomination is coins of I minus 1, right? That's how you calculate that. That's the value that we take. 3 minus 2, that's 1, and we take this particular value, right? this is that value. Okay, that's how you do it. That's it. I think that's the solution. And we return dp of -1 -1. Let's try to run this. Okay, that's accepted. Let's submit. Yeah, that's how you do this particular problem. If you have any questions, let me know in the comments below.